Notes 13, page 11, more test review. Simplify, do not leave negative exponents. This is very typical of a problem that might be on your test. So, pause the video, give it a shot. I'm going to go ahead and go over this. So, I'm going to notice there are two terms. So, when I see that, I essentially have two big problems. It's this, simplify that term, simplify that term. Then we'll see if they're like terms. So, I can reduce my problem just to dealing with this, and this doesn't look too bad. I'm going to simplify that term. Now, be careful. Exponents before division. So the only thing being squared is the numerator. So this is a product in parentheses, so you can distribute the exponent to each factor. So that's going to be 4 squared, which is 16. M squared squared, power to a power, you multiply exponents. That's m to the 4th. P cubed squared, p to the 6th. All over 6m to the negative 1st, p to the 4th. Okay? I'm going to move that, because this is all factors. The numerator of this term is up here, so I'm going to move that m to the negative 1st up. All right. And now I'm going to reduce. 16 over 6. You know what happens? When you're dividing like bases, you subtract the exponent, so that's going to be p squared. So I get people subtracting 16 over 6. Those aren't exponents. 2 goes into 16 8 times. 2 goes into 6 3 times. So the coefficient of that term is going to be 8/3. P to the 4th, 4 of those will cancel. With 2 of those, that'll be p squared. M to the 4th times m to the 1st would be m to the 5th. So that's 8/3 of an m to the 5th p squared. You can also write it like this, all over 3. Doesn't matter. But you should realize the type of term this is an m to the 5th p squared, and you have 8/3 of them. That's your coefficient. All right. Now let's look at the other term. Common mistake, and I will be checking to see if you notice things like that, like this. This is a double negative, so this is really plus. All right, this is all multiplication. I can ignore the parentheses because multiplication is associative, and I can reorder. Multiplication is commutative, so I can just think 1/2 times 2. I've already dealt with a negative. Negative times a negative is a positive, so I just think 1/2 times 2, that's just 1. M to the 7th times m to the negative 2nd. Now that is multiplying the same base. It's long distance multiplication, but I'm multiplying the same base, so I add the exponent, so that's m to the 5th. And then don't get, sometimes this happens, don't get sloppy. P to the 1st times p to the 1st is p squared. All right, so now I have that term simplified, and I can look at the two terms, and they are like terms. And when you're adding like terms, you're just counting how many of these m to the 5th p squared you have. And the coefficients count how many, so I just add the coefficients, and if you want to, you can take that off to the side. And it's an easy problem. LCD is just 3, so 1 is 3 over 3. This is just 11/3. So it would be 11/3 m to the 5th p squared. You could also write it as 11 m to the 5th p squared all over 3. Doesn't matter. All right, so again, I do have a tendency to have multi-step problems because as you go on, most of the problems do tend to have many steps. You don't build a bridge in just one step. So you have to get used to that. And you just got to keep your focus. So this next problem, now, occasionally I do something like this on the test. We've never actually done a problem exactly like this in the homework, but we've done all the elements that you need to do this problem, we've learned. So sometimes I might put some problems together kind of in a unique way and see if you can think on your feet. So take a second, see if you can simplify that. And when you think you've done it, turn the video back on. Okay. All right, so I'm going to go ahead and go over this. I do want to tell you, if you remove the i's, that's exactly like the type of problem we've done before and high probability for the test. There are two terms, and I realize it's this answer. I need to get that answer minus this answer. So when I get the answer for the second term, I got to distribute that negative. I will be testing to see if you recognize the square of a binomial. That's probably going to be on your test more than once. So that is the square of a binomial. If you haven't learned your pattern yet, remember it's the same factor twice. You can write it out twice and FOIL it, but I'm going to use the pattern. Pattern says square the whole first term. Don't forget to square the 3. So that's going to be 9i squared. Then it says multiply the two terms together. Well, that's lovely. 6ix, but double how many you have, so it's 12ix, and it'll be minus, because that's minus. And then plus, and this is the most common mistake when people use the pattern. That last term is positive. Look at it. If you FOIL it, last times the last is negative times the negative. So that's plus, don't forget to square the 2, 4x squared. Now, you do not have to have parentheses around here because there's an invisible plus sign. If you want to have parentheses around it, you can, but you don't have to. However, here, subtraction is not commutative, so you better have your answer in parentheses. So, this problem is just a FOIL problem. A binomial times a binomial. I don't care what the two terms are here. It could be a cow and a pig. I think we've done that. It's a FOIL problem. So 2i times 2i is 4i squared. 2i times negative 7x is a lovely minus 14ix. X times 2i is plus 2ix, and then minus 7x squared. Okay. Now, here we do have like terms in the middle, and you can opt to add your like terms in the middle first, or you can opt to go ahead and distribute the negative. I won't care. It doesn't matter. I'm going to go ahead and distribute the negative because of space. This is going to be 4i squared plus 14ix minus 2ix plus 7x squared, and then bring down this 9i squared minus 12ix plus 4x squared. Now, I am going to go ahead and just collect my like terms. Many of you remember you got to do something with that I squared. You could do it now because I squared is -1, or you can do it later. I tend to wait and do it all at the end. I'm just going to collect my like terms. 9i squared minus 4i squared is a positive 5i squared. Okay, now check this out. Use another color. I'm going to start over here. It just makes it a little bit easier. 14ix minus 2ix is positive 12ix. But then you subtract 12ix, that's 0. Oh, that weird term, ix term, it goes away. Isn't that nice? And then we have 4x squared plus 7x squared. So that's plus 11x squared. Now I'm going to remember I squared is -1. So this is 5 times -1 plus 11x squared. This mess is just 11x squared minus 5. all that turned out to be. Okay. Now, this next thing, yeah, I am definitely probably going to ask you something like this. This is so important. Now, I didn't put these equals in here. Probably should have. This expression is equivalent to that one. They say the same thing. This is just an easier way of saying that mess up there. So, if you're asked to evaluate this mess here, if x is 2, I mean, you could plug a 2 in and try and mess with that, but if you simplify this, you realize it's equivalent to 11x squared minus 5, which means if whatever number I plug in here for x, I'm going to get the same answer as if I plug in here for x, because that's what equivalent expressions do. So I'm going to use the simplified form. 11 times 2 squared minus 5. 2 squared is 4. 11 times 4 minus 5. 44 minus 5. It's just 39. There is an advantage to simplifying. All right, so that was our review, and the huge midterm is what's next.